we are going to investigate the effects of salinity and pH on the growth of mung beans in our experiment. According to many research findings, although sodium chloride is an essential trace element for seeds, they cause phytotoxicity to some bean types. Therefore, we would like to investigate whether sodium chloride in different concentrations would pose an effect on mung bean growth. For the choice of pH, scientific researchers have confirmed that variation of pH will cause an effect on the growth of mung beans. Unsuitable pH, either too low or too high, will cause essential mineral malabsorption that lead to poor mung bean growth. Therefore, we would like to know if mung beans can adapt to extreme pH and how they are being affected by pH changes. For the data in our experiment, the average length of the stems of mung bean measured by a metric ruler was used as the indicator of growth of mung beans. As we want to make sure that the growth of mung beans is significantly influenced by our manipulation of pH and salinity, pilot tests or preliminary tests are carried out so that we can determine the suitable range of pH and salinity for observable and reliable results. Before the actual experiment, we grow the mung beans at pH 0, 2, 4, 6, 8 and 10 and the salinities of 0, 0.4 and 0.8 molarity for 5 days in darkness with standard room temperature and humidity. After the preliminary test, we decide to choose buffers of pH 3, 7 and 10 and salt solutions of 0, 0.4 and 0.8 molarity for the real experiment. In the experiment, we will divide the mung beans into 9 groups or cells, with each pH crossing with each salinity. Therefore, they are in a 3x3 crossed design. Each cross will then have 3 replicates, with each replicate containing 10 beans. In total, 270 beans are utilized. In this experiment, salinity and pH are the 2 factors, which are used to test their impacts on the growth of mung beans. In order to use a metric test, 3 assumptions need to be checked. First, there should be no outliers. Second, homogeneity of variance needs to be checked. Lastly, dataset must follow the normal distribution. After checking these assumptions, 2-factor ANOVA will be used. 2-factor ANOVA is used because we aim at assessing the effects of salinity and pH on the growth of mung beans. We can also find the interaction between the salinity and pH on the growth of mung beans. However, data tested should have homogeneity of variance before conducting 2-way ANOVA. Therefore, Levene's test will be performed. If the data accepted null hypothesis, 2-way ANOVA will be performed. For 2-way ANOVA, there will be 3 hypotheses. The 6 null and alternative hypotheses are listed. After conducting ANOVA, by accepting or rejecting null hypothesis, the effects of salinity and pH, together with their interaction on the mean growth of mung beans will be found.